In the Spider-Man video game for the PlayStation 4, there is a mechanic where Spider-Man shoots his web at an object and proceeds to swing it and throw it at an enemy. In this clip, Spider-Man shoots his web at a trash can. Since the game takes place in New York City, this means that the trash can will weigh around 50 kilograms, so we can write that down as our mass. In this frame, we can see that the web is a bit longer than the full length below it. Assuming that the average American is around 1.76 meters tall, we can safely assume that the web is around 2 meters long, which will be the radius for our equation. Timing the time it takes for Spider-Man to swing the trash can for one full rotation will give a readout of about 0.15 seconds, which will be our time. Now that we have all our variables ready to go, we can start by calculating the circumference of the circle. To get the circumference, we multiply pi times the diameter. With the circumference and the time, we can also calculate the velocity, which comes out at about 83.7758 meters per second. Since we're trying to calculate force, we will be using this formula. We substitute m for 50 kilograms, and we substitute velocity squared for 83.7758 squared, divided by the radius, which is 2. When we do the operation, the result for the centripetal force is equal to 175,459.61664 newtons. But what does this number mean? Well, we can divide it by the force of gravity, 9.81 meters per second squared, to get 17,885.79 kilograms. This means that Spider-Man is outputting the force required to lift 17,885 kilograms. This is the equivalent to lifting 14 sedans. As incredible as this sounds, it is actually accurate to his comic book strength. In the 694th entry of the Amazing Spider-Man comics, he carried a jet, and jets weigh a minimum of around 80,000 kilos, which means that, according to the comics, Peter Parker would easily be able to output 175,459 newtons of force.